Hello again. Okay, again, preliminary analysis shows that ignoring the -1 and the +1, we have an n over n root n, which is like n over n to the 3/2, which is like 1 over n to the half. So we suspect divergence, and we're going to use 1 over n to the half to compare it. Now, in this one, I'm going to put in that I don't want you to think it makes any difference. I'm going to put that 1 over root n in the denominator. You can put it either place for this test. It makes no difference, numerator or denominator. Okay, so here's my problem. And I'm going to find this limit. Let's see, it'll be a root n, then n minus 1 up here, and an n root n plus 1 down here. Okay, it reduces to, looks like we have an n minus 1 and a root n with a root. Whoops. Root n plus 1. Okay, now that's the same as this, n minus 1 over the square root of n squared plus n. Okay, now notice again, we kind of have an n over n here, so I'm going to divide by n, the highest power magnitude. We'll say highest power of x, the magnitude would be n. So I'm divide everything by n. And underneath here, when you divide by n, it brings it as underneath the radical as an n squared. So I have an n squared here. N squared. That will reduce now to, let's see, you're going to have 1, oops, 1, no, we don't want that. Okay, 1 minus 1 over n over, down here we'll have the square root of, and by the way, that was an n squared when it came in there. So we have a 1 plus 1 over n squared. And I think we can easily see now at this point, as n goes to infinity, we're going to get a 0 up here, 1 minus 0, and down here 1 plus 0. So we will have a 1 as our limit, which is positive and finite. Therefore, by that, the limit comparison test now, we have two divergent series. So divergent by the limit comparison test.